Launch conductor, proceed with terminal count at the end of the built-in hold. Roger.
April 15th, 1999.
T-minus 20 seconds. We are go for launch.
A Delta II rocket lifts off from Southern California's Vandenberg Air Force Base.
And liftoff of the Delta II rocket with the advanced Landsat 7 spacecraft.
Its payload, Landsat 7, the seventh satellite in the series, part of a decades-long collaboration between NASA and the US Geological Survey. Its mission: to continue the Landsat legacy by providing a continuous detailed portrait of Earth's changing landscapes. Just 3 days later, 438 miles above the Earth, Landsat 7 would use its Enhanced Thematic Mapper Plus, or ETM Plus, the most sophisticated Landsat sensor yet to capture its first image above Sioux Falls, South Dakota. For the next 2 decades, Landsat 7 would circle the globe every 99 minutes, collecting high-resolution imagery of our planet's surface across 8 distinct spectral bands from visible to thermal infrared every 16 days, from agricultural monitoring to urban planning, disaster management to climate research. Landsat 7's data is essential for scientists, policymakers, and communities worldwide to continue the record of our changing home planet over the last half-century. One of Landsat 7's most valuable contributions was its ability to classify and map different types of land cover on a global scale and how they change over time, by distinction between forests and wetlands, urban areas versus agricultural areas, like this map of Portland, Oregon, assembled from the data collected over the course of 2001. Scientists could monitor ecological health, plan for sustainable development, and better understand environmental changes. The data Landsat 7 collected across the visible spectrum helped detect early signs of drought, stress, and disease, allowing farmers to make better management decisions, ensuring healthier crops and higher yields during catastrophic wildfires. Landsat 7 became our watchful eye from above, mapping the extent of burned areas, helping firefighters strategize, and assisting communities and other stakeholders in recovery and resilience planning. And Landsat 7's utility wasn't just limited to the land, playing a key role in the Millennium Coral Reef Mapping Project. Its ability to capture detailed cloud-free images over remote tropical regions proved to be a critical tool in helping scientists create the first consistent global map of our planet's coral reefs. And Landsat 7 imagery played an integral role in the Landsat Image Mosaic of Antarctica project, helping to create the first ever true-color high-resolution satellite view of the Antarctic continent. The Landsat 7 mission, however, was not without its challenges. In May 2003, the onboard scale line corrector, a key component of the ETM Plus meant to compensate for the forward motion of the satellite, malfunctioned, resulting in gaps in the imagery and creating noticeable stripes of missing data across scenes. Despite this setback, 78% of the data from each scene remained intact, and scientists at NASA and USGS, along with significant contributions from university-based members of the Landsat science team, were able to quickly develop techniques to compensate for these gaps, enabling the Landsat 7 to continue providing valuable imagery and scientific insights for many more years. Landsat 7's nominal science mission came to a close in the spring of 2022 as its orbit was lowered, following the launch of Landsat 9 the previous fall, and despite surpassing its original expected 5 years lifespan by nearly 2 decades, Landsat 7 continued to collect valuable data even at its lower altitude. Unfortunately, Landsat 7's lowered orbit led to increasing drift, which impacted battery maintenance, imaging opportunities, and data processing. As a result, the USGS decided to bring an end to imaging, with Landsat 7 collecting its final images above Las Vegas in May 2024, returning to where it had collected some of its first imagery 25 years earlier. In those 25 years, Landsat 7 captured over 3 million images of our planet, collecting data that would be used in over 2,000 scientific publications, generating billions of dollars in economic benefits, and paving the way for the development of new and improved instruments for future Earth-observing missions. The Landsat 7 mission established new high watermarks in the Landsat Earth imaging program with respect to quality, quantity, and repetitive global coverage, creating the new baseline standard for future Landsat missions to match and surpass. The sheer volume, exceptional quality, and precise calibration of Landsat 7's data have provided humanity with a deeper and broader understanding of our planet's land surfaces and their changes over time. Data that will remain a core component of the extensive Landsat archive, continuing to support scientific innovations long into the future. So after USGS engineers powered down its batteries for good in 2025, we bid Landsat 7 a fond farewell. Thank you for over 2 decades of unprecedented vision, forever reshaping how we see and protect our home planet.